Hey everyone, welcome to my YouTube channel, Amma Code. My name is Amma, and this is my very first video on YouTube, and I'm super excited you're joining me on this journey. A quick intro about myself. I'm currently living in London, working as a software engineer at an e-commerce startup. Originally, I moved to the UK to study data science, and fun fact, that's the same year in which ChatGPT was launched. And to be honest, as we know, software engineering hasn't been the same, right? We now have a new breed of professionals called the AI engineer, which is the intersection of, I would say, data scientist skills on one side and software engineering skills on the other side. And this has led also, I would say, to the rapid rise, I would say, of people with such skills, as we can see in this graph, where we have, like, I would say, in purple, you can see a steady, I would say, graph, right, with AI engineering going at a rapid increasing pace compared to the traditional role of the ML engineer. So at the heart of this AI revolution are what we call LLMs, known as large language models, which I'm sure a lot of you have come across, right? So, what is, I would say, the objective and the goal of this series? Well, I would say I just want us to go beyond the typical tutorials of calling an API either from the big labs like OpenAI, Anthropic, and also Gemini to build a chatbot. I think there's a lot of that, which is good, so don't get me wrong. But I think, or from my own experience, I like to go under the hood to understand how things function. Just the same like driving a car is cool, but when I have friends that I would say like know a lot about, I would say, the engine of a car, they talk about the horsepower and other mechanism of the car. I find that super exciting, right? It's just something that I would say drives, I would say, my curiosity and actually gets me to actually like want to go hands on and code. And so it also makes me to also reflect about an experience I had, I would say, in 2023 when I attended a Pi Data event here in London. And the speaker asked how many people have used OpenAI API, and nearly all of the hands went up. That was interesting, right, at the time. But when he asked, how many people have trained or fine-tuned your own LLM? And guess what? Basically, most of the hands were down. And that's when it hit me. APIs, I would say, are everywhere, but the skills to build and customize LLMs are really in demand, and there may be different reasons, I would say, why people want to develop, I would say, or not develop, it's going to be fine-tune their own LLMs. And most of the time, you always have, like, I would say, small LLMs for this reason. There are different reasons, and we're going to come to this, but I would just say some of them, you have privacy, domain-specific apps, and sometimes, just out of sheer curiosity, what is happening in the big labs and how can I do it? And before we also continue, I also like to give, I would say, credit to Sebastian Rashkan, which wrote this popular book on training an LLM, which I'm just going to bring a little bit closer to the camera. Build a large language model from scratch. This book also, also helped me to be inspired for, I would say, the video series I'm making currently. But I'm also going to be using it as a guide, also getting, I would say, other content from different, I would say, sources of the internet and also papers I've read. And I also advise you to definitely check out the book because it has a lot of, I would say, good, I would say, practices on how to build an LLM. And there's also a video series which Sebastian also has. And so before we go forward about, I would say, LLMs, I also like us to go back, I would say, into what brought us up to this point in time where we are, right, to know what happened before, I would say, the AI boom. So, just to let you know, NLP, which stands for Natural Language Processing, existed long before, I would say, ChatGPT. But back in the day, we had models that were trained for, I would say, narrower tasks, like spam classification for, I would say, your email, right? Sentiment analysis, like Twitter sentiment analysis, or social media and all that. translation, right? You had Google Translate. I mean, it was not before, it existed before ChatGPT, right? But there's one thing that most of these, I would say, NLP techniques had a problem with, and they really struggled a lot with open-ended tasks like writing coherent text or generating code. And that's one of the things in which I would say, fast forward in today's, I would say, large language model driven AI revolution. Models like from, I would say, from the big labs, right? Like either ChatGPT, Claude, Gemini, and God can handle any text base, from summarizing legal documents, and also, I mean, writing rap beef battles like what Drake used to write the popular diss track Tailor Made, in which AI Snoop was used and AI Tupac. And I'll demo that, I mean, later on in the, I mean, in this video, just for us to have a little bit down and just to say, I mean, our experience, how far we've come, right? And you also have also other generative, I would say, models for like videos, image, and all of it. But it started with what? It started exactly with LLMs. So basically, what is an LLM? Well, I mean, an LLM is basically a neural network trained on massive amount of data, right? Text data to understand and generate human-like response. So it is a subset of generative AI, which is also a subset of AI, right? And so this, I would say, generative AI enables us to produce, I would say, different form of medias, right? Be it image, videos, and audio, right? And you can see that like the G in ChatGPT stands for what? Generative, right? And you can see that there's an overlap between NLP and large language models, right? But our focus is going to be on I'll say the subset of large language models. So I mean, one of the things that lies at the heart of this large language models revolution is the architecture of the transformer. And I'm sure most of you have already seen or have heard or have come across the transformer architecture, right? Which in this diagram looks a little bit scary, but we're going to cover it. So the transformer architecture was introduced in the legendary, excuse me, I got a French accent, so sometimes to pronounce some words in English is a little bit tricky. So it was introduced in the legendary paper of Attention is All You Need in 2017 by researchers at Google, right? And also some, I would say, collaboration from people in the University of Toronto, right? So that is, I would say, the key architecture that made it possible for everything we're experiencing today in terms of coherent text generation, understanding in the form of machine, not human understanding of language. And so I also like us to come back to this transformer architecture, but let's, I mean, go back to one of the slides we saw earlier, right? So this is the paper, Attention is All You Need, and you have the name of the collaborators, which have also gone to do great things, right? And so let's go back to the slide we had earlier with the different subsets, and I would like us to touch about machine learning versus deep learning. So what is machine learning? Well, machine learning are algorithms that learn patterns from data, right, based on human crafted features. While on the other side, deep learning are just neural networks which automatically find patterns in raw data, making them perfect for messy unstructured text data, right? And so basically, like, you have like a neural network that is just like basic neural network which goes through a forward pass process, right? And through the different layers with an activation functions that is fed down through the layer to the end of the output, where we have a loss function that measures the, I would say, difference between the training data and also the expected output, and then it's now passed forward to, I would say, the network back. This is the forward pass, and then you have the backward pass which optimizes it through, I would say, gradient descent, right? And so, I mean, why do, I would say, smaller LLMs matter? As we touched on it earlier, but it's also good that we come on it to really like understand why it is important for us to develop the skills, I would say, to fine tune or to train an LLM, right? But in this case, we mostly be fine tuning, but we're going to touch, I would say, training or pre-training, right? When we come to that, it's just because I would say, first, it's cheaper to train and run, right? You have lower, I would say, resource usage. It's also computationally efficient. You don't need a lot of GPU clusters, right? And at the same time, for privacy reasons, you're not sending your data to the big labs, right? So there's also the aspect of it. And also, I mean, if you talk about deployment on edge devices, be it on, I would say, phone laptops, which is something which Apple is currently working on, it's still better. And also talking about, I would say, like in performance, right? It's also better performance than the big models because it's trained on domain specific tasks. And one of the examples that comes to mind is also like you have the popular BloombergGPT paper, which was I would say an LLM trained on just financial data, but we saw it greatly outperform ChatGPT in finance related tasks, right? So you have the power of specialization in this context, right? Because it changes on a specific domain, right? And so for these different reasons, it's one of the reasons I would say like it's also good to have, I would say, fine-tune data for your own tasks. And also there's a lot of open source LLMs that we can just get the weight to fine-tune on it. So what are the different phases, I would say, in LLM development? Well, let's just look at it. There are two main stages in LLM development, right? You have the pre-training phase that you have here in the middle, and then you also have like the fine-tuning. So on the left, we have raw data, which is made up of text data from the internet, books, Wikipedia, and research articles, right? Which goes through the training process, and you have, at the end of this, you have a foundation model, or what is also called a base model. And at this stage, the LLM has only a few basic abilities, which is like text completion and some few short learning. Few short learning basically is just an example of where you have, it's simply a question and response, like a prompt and a desired output which you put in the model, and the model is able to produce similar response, right, based on this prompt and response pair that you show the model. So it's called few short learning because it sees just a few examples. And the whole process of pre-training is just that you should think of it like somebody that goes in the library and reads a lot of books, but comes out and doesn't really have, I would say, specialized domain knowledge in a certain subject, just like how we go through preschool and we learn a lot of subjects, but later on we specialize in a particular field, right? So that's like the pre-training phase, and then the fine-tuning is where we get the specialization. So the next phase after the pre-training model, where we have now a labeled smaller data set, right? For example, it's now going to produce, I would say, tasks like classification, label, summarization, or instruction pairs. So this phase gives us what we call a fine-tuned LLM that can specialize in any task like translation, classification, or even just a personal assistant. In the case of what ChatGPT as we know it, or Gemini, and all of the other, I would say, chatbots from the different big labs, right? And so let's go back, I would say, to the transformer architecture, which we touched on earlier, to just have a broad level understanding of, I would say, the key components in this architecture. Later in the video series, we're going to go down into, I would say, the different steps involved in actually like coding a transformer architecture from the ground up, right? But from a high level understanding, there are two main things in the transformer architecture, or two main components. You have the encoder on the left side and the decoder. So what does the encoder do? Basically, it takes in an input sentence, and in this our own case, this is an example, and it goes through, I would say, a pre-processing phase, which entails converting the text into embeddings, right, which are numerical representation that capture context and meaning, right? And then now you have an output, which is, I would say, these embeddings, which is fed into the decoder, as you can see in this case, right? And so the decoder also, this is the original transformer architecture, right? So we have to keep that in context, which was used for translation. And in this case, it's the German language. So we have, excuse me, German, but I'm gonna try. And in this case, is that is n bezel, one word at a time. So this input is fed into the decoder with the output from the encoder label, from the encoder, which is an embedding. And so what does this enable? It enables the decoder now to take this to input and produce the next output, right? Which is the complete sentence of the German text, right? And so you notice the difference, I would say, between the encoder and the decoder, right? Where the encoder sees the whole input sentence at once, right? This is an example. Why I would say, decoder only produces output one step at a time. And as I said earlier, this is the original encoder decoder setup, which was built for translation in the original paper. But it became the foundation of the modern NLP as we know it. So now let's look at what is different in GPT, or how the GPT architecture differs, even though it uses the transformer architecture from the original transformer paper, right? So in the GPT architecture, it's made up of only the decoder model. So there's no encoder model in it, right? And that's where I would say it changes the whole game, right? But still, I mean, it's still larger than the original, I would say, transformer architecture used in the original paper, right? But yeah, we see that in this case, right, where it's about, I'll say it's token, it's text generation one, output at the other. We see that three different phases, right, or three different iterations in which it goes with the decoder only. The first is the input sentence, which goes through a pre-processing, is this, and at the output of the first iteration, we have this is, right, and it's fed into the second, I'll say, iteration within the second decoder, right, which goes through the pre-processing again, produces the output, this is and the text from, I would say, from the second iteration is fed into the third iteration, and it produces, this is an example. So we can see that the three different iteration stages enables the model to generate, I would say, one token at a time, right? And this is called autoregressive text generation, which is predicting one word at a time until you get the full sentence. And while the original transformer, I would say, had 6 encoder decoder layers, right? Well, GPT took it up to the next level. It had 96 decoder layers. So you see a big significant difference where, like, the original transformer, which is made of the encoder and the decoder, has just, I would say, 6 layers, right? GPT has 9, okay, and 96 layers, and it's made up of 175 billion parameters. Well, I mean, just to let you know, that means we can't really like train that on a laptop. That's not even conceivable. I mean, basically, if you had to run it on a laptop, it's going to take like I think, if I was wrong, like it's going to take like forever, or like a billion years, right? So it's not even visible. It's something we can't even like phantom run it on a laptop. So what we're going to do is we're going to train a small, very smaller model. And just for full disclosure, so you should know what we're talking about, training GPT-3 costs an estimated 4.6 million in cloud credit. Yeah, and that means what? We can't do that on my poor MacBook Pro, because that's going to basically like blow it up. I mean, it can't even go through, right? So as I said earlier, in this series, we'll be training a a small mini model for learning purpose, and also using open source pre-training weights for real results. And so, I mean, let's just lay down the roadmap of this series so we know where we're going to. So, and this is just basically what we're going to be doing, right, in 3 stages. In the first stage, we're going to be doing data pre-processing and building the attention mechanism from the ground up. And in the second stage, we're going to be coding and pre-training a GPT-like model on a toy data set and also evaluating it. And in stage 3, where it gets really interesting, we're going to be fine-tuning a pre-trained model for tasks like classification and instruction following, as you can see here, right? So we have a personal assistant in our own case. And by the end, I mean, you won't just use an LLM, you will know how to build and customize one. And so a summary of what we've done so far, right? We've seen that LLMs are just like deep learning models based on the transformer architecture, which revolutionized the way NLP is done as a whole. And then in the training, we've seen that training is composed of pre-training and fine-tuning, right? Pre-training produces the foundation of a base model, and fine-tuning produces a specialized model, right? That is good in a specific domain or task. And we see that, I mean, GPT, which stands for Generative Pre-trained Transformer, is made only of the decoder-only transformer for text generation, right? Even though now we have different models for, I would say, like multimodal models, right? But that's something not for this, I would say, series. Okay. And we've also seen that more specific domain LLMs are better at the future, right? Because of privacy or for efficiency. And all together, we're going to be coding this one step at a time. So that's it for today. And in the next video, we're going to dive into the historical context of NLP and see how unpacking and to see how we can unpack how the transformer was built, right, and how it changed over time, and also like building up from scratch and understanding the mechanisms or the layers that are involved in making the transformer so efficient and good. And if you're excited about building your own LLM, please hit the subscribe button. You can give me feedback in the show notes, right, or also like in the comment section. I'll also be leaving some of the resources for, I'll say, the book which Sebastian Rashkan wrote, and also the video lectures and other, I'll say, interesting material for you to check out. Until then, see you in the next one, and let's just have, I'll say, a quick listing of the two-part AI video generation with Sunup that was done by Joy Wright, which I mentioned earlier. Hope you enjoyed it.
Kendrick, we need ya, the West Coast savior. Ain't Grady your name, it's some hip-hop history. If you deal with this vicious